Okay guys, I forgot to talk about number 65, which is another fraction problem. And this is an example from the textbook. So first of all, this answer key is 6.1 worksheet number 2, which has to do with the solving part. The first part had to do with simplifying and combining like terms, evaluating, stuff like that, order of operations. So this is the solving part. So I want to take you to number 65. And I would like to do it two different ways, okay? So just to show you the difference between my LCM method and actually just not doing the LCM. So we'll see what the difference looks like. So first, let's do it by not doing the LCM. So in other words, I'm going to say, hey, I have like terms here. So this is a like term. I'm going to simplify that. But I have to do basically, that's 2 1/4, which I can convert that into, 4 times 2 is 8, 8 plus 1. So this is 9/4. Now another way you could have done that is by doing common denominator on the side here. So having to change this to a 4. So that's times 4. So yeah, I was right. So then you gotta get this whole 8 over 4, and the 8 plus 1 is the 9/4. Okay, either way, you're gonna get this here. Okay, so now some people pretty much get stuck right here because they don't know what to do with this fraction. And basically the trick is to remember, at least another shortcut is to do multiply by the reciprocal, okay? Because reciprocals like 4 over 9, if you multiply that, that's basically 36 over 36, which is 1. Or in other words, 4 divided by 4 is 1, 9 divided by 9 is 1. So we get our nice x here. But whatever I do to the left side, I must do to the right. So again, you have to deal with this, all these fraction techniques that you have to remember. Mixed numbers, common denominator, multiply by reciprocal. Now here I gotta multiply fractions. So basically I gotta get, I'm gonna get 4 over 27. Okay, so let's see if you use my method. So you think of the LCM, and between 4 and 3 is 12. Okay, so now we just do 12 here, 12 here, and 12 here. So 12 divided by 4 is 3. 12 times 2, because that 2 is not in the bottom. Okay, there's actually a 1 there, right? So that's not going to divide, it's actually going to multiply. So that's just 24x. And then this right here, 12 divided by 3 is 4. And then I add these two up here because they're like terms. And I get, so notice the fractions are totally gone. Gives me 27x. And I'll divide both sides by 27. And as you can see, we get the same exact thing. Okay. So I will be putting this on your video check, and you can do either method, doesn't really matter. But I will say, please write down the question and answer for number 65 in the method of your preference, or something to that effect. Okay, so you don't have to copy both of these down for the answer, you just have to do one of them. So let's go to actually writing an equation, okay? And we're gonna skip the solving. Well, we'll see. We'll see how it goes. Okay. We might do the last one. So, a number decreased by 5. So a number is something we don't know. You can call it n or x or whatever you want. I'm just going to use n for number. So there's a number. It's being decreased by 5. And it says, so this is minus, all right, is, that's equals, okay? So is 10. So a number decreased by 5 equals 10. Number 8 is 16 increased by, that's plus. So 16 increased by what? Increased by 8 times a number. So that's 8n, 8 times a number. Is the equals 88. Okay, now you guys, we've done plenty of those. What about number 9? So number 9 says a number n divided by 3, okay, divided by 3, that's easy enough, is, okay, equals, now it's going to say 4 less than the number. So the same number, we got to subtract 4 from that. Okay, remember, you got to write it in reverse. Okay, so how would we solve this one if we have to solve number 9? Well, I can get rid of this 3. That's basically our annoying fraction, and we can say, well, let me multiply everything by 3. And that will take care of my fraction. It's going to clear that out. So that means this is going to be a 1. And this is going to be 3n minus 12 as we distribute. And then we want to move the variables to one side. And I'd rather choose, well, what I can do is I can move this 12 to the left. Okay, so we can kind of say, hey, negative 12. If I move it to the left side, when I cross that equal sign, and now he's positive. And if I move the n to the right, that's going to be 2n. Okay, and then that keeps our variable positive, which you don't have to do it this way if you don't want to. But then just by inspection, 2 times 6 is 12, so n equals 6. Okay, or divide both sides by 2. Okay, guys, so now we've reached the point of 6.3 where we are solving. We have to interpret, after we read the word problem, interpret it, translate it, and try to solve it, okay? Solving part is not going to be too bad. It's really the first stage, which is understanding the setup, okay? So here we go. So on page 301, in your text, you have a nice general procedure to solve a word problem. So let's take a look at this. Okay, so first of all, read the problem carefully, all right, at least twice to be sure you understand it, okay? So you're looking for understanding the general scenario, okay? Now, if possible, draw a sketch because you want to visualize. So understand, visualize, and then once you understand and visualize, then you want to know, okay, well, what is it that I'm actually finding? Okay, what are you being asked to find? Choose a letter, X, Y, Z, doesn't really matter, for this unknown quantity, and then write down exactly what this letter represents. Do the equation part, solve it, and then you're not done after that. You need to answer the word problem. Okay? because just by getting a number doesn't mean you answered it. You need to answer it in a sentence, okay? So we'll come back to this as we do the first one here. Talks about Sam, who's working at Olive Garden. Okay, so the weekly salary, okay, so this is not monthly, it's not daily, it's weekly, so that gives us the time frame. And how much and where, well, it's not really important where. He also receives a 6% portion or percentage of the tips collected for the week. Okay, so he's getting paid two different ways. And so this is part of the understanding. All right. So we have and then we see the word total here. So we have, okay, so what's my total weekly amount earned? Okay. Well, that's going to be a salary that's weekly. In addition to that salary, you're going to get 6% of the tips. Okay, so this is how you can visualize what's going on. I'm getting paid. How am I getting paid? Two different ways. What are the two ways? I get a base of fixed amount. Okay, and then you get a percentage which can change. It could be, if you do, there's a lot of tips one week, you're gonna have more. You're gonna get paid more. If there's less tips, you're gonna get paid less. So that part is always gonna be variable, or just gonna change. So now the question is, here you see a goal. Okay, there's a goal here. I want a total. I want to, try to make $350 every week for whatever reason, and maybe it's to pay off bills or save up for a new car or whatever. Okay, and so we know totals have sums, and there's our sum right here. Okay, and those are the two things. So we just need to fill in the blanks here. So the goal for the weekly amount is $350. The salary from the word problem is $200. 6% needs to be translated into 0.06. Okay, it's not 0.6 because 0.6 is 60%. 0.06 of means time, so 6% of X, okay? Because we don't know the tips. We want to know what this is, okay? What must be the tips? So let X equal tips, or I can put weekly tips. Okay, so now we've set up our equation, then we just go ahead and solve it. So we're going to subtract 200 from both sides. That gives us 150. Divide both sides by 0.06. And we get X equals whatever this amount is. So we put that in our calculator and we get the number 2,500. So to answer this question, we say, okay, that number for X, now I'm going to translate it into a sentence. What must the tips be in order for Sam to make a total of $350 per week? Sam must have 2,500 in tips per week. Okay, that is the answer. Sam must have 2,500 in tips per week in order for him to reach his goal of 350 per week. Okay, let's take a look at number 11. So Hollister has a sale offering 10% off all jeans. If Amanda spent $207 on jeans before tax, what was the total purchase before the discount? All right. So what is going on here? We have somebody spending money, right? But the amount that is paid is less than the original amount. How do I know that? Because there's a sale going on, and that sale is 10% off. Okay? What does that mean, off? Well, that means 10% off the original price. So when you're building your equation, actually when we visualize, we say, wait a second, we have the original price. Okay. She's not going to buy the original price. She's going to make sure she gets a discount, buys it when it's on sale. So the original price, you subtract whatever the discount is. So it's 10% off. So what they do at the register is subtract that sale off. So that is going to be 10% off. Okay. And that is what she's going to pay at the register. Okay, or the amount spent. Oops. And we have that right there. Okay. So what is the X? Well, we know the amount spent is 207. What we don't know is what the original price is. Okay, so let X equal the original price. And you can see it where the question mark is. What was the total purchase before the discount? That's the original price. Okay, so X, that means this is going to be X minus 0.10. And then off of what? It's 10% off of the original. So I got to put, so we're not going to subtract 10 cents, guys. If you don't put the X here, what you're doing is subtracting 10 cents. And that's not possible, okay? That doesn't make sense. It's 10% of the original price. So the original price, or the X, is repeated in this case. We have the original right here. And then 10% off the original. Okay, that's what they do at the register. Okay, so if let's say the jeans were $100, and you know that 10% of 100 is $10, so 100 minus 10 would equal 90. Okay, that's just a quick example. So this is what we don't know and we're trying to figure out, but we do know as a clue is that she spent $207. So now we have basically a 1x minus a 0.10. That's like saying $1 minus 10 cents is 90. So basically we have, if you combine like terms here, we have 90. And what this is basically saying is, if you have 10% off of something, you're going to pay 90% of the original. Okay? So actually, you can do that part in your head, but we're going to just build it from here. and get 207 divided by 0.9 is going to be 230. Now 230 is not an answer. Okay. Yep. So the original price of the jeans before the discount is $230. Okay, it's a sentence. The original price of the jeans is $230. Okay, we got to get away from just throwing numbers and X's around and just saying that you're done. Okay, that's just the algebra that was used as a tool to figure out this real world problem. Okay, so let's take a look at number 12. This one's a little different. So we have Lauren and Brittany. Those are two people involved here. And we got the word together. Okay, that's like total. So Lauren and Brittany together plus receive 16 free iTunes songs for joining a music club. How many iTunes songs will each receive if Brittany is to have, now here's the clue that you have to translate, 3 times as many as Lauren. Okay, so let's put this in perspective here. Let's visualize. So remember, we have, we still don't have an actual picture, but we can visualize. Okay, we got 16 free songs, okay? And they're going to get, Lauren and Brittany are going to share that. So what we don't know, so we have Lauren plus Brittany together are going to receive 16 iTunes songs. Okay? So we have 2 variables. But here's the clue. Brittany, or the B, is to have, now here's the translation, 3 times as many as Lauren. So whatever Lauren has, Brittany's going to have 3 times as much. Okay, that's the clue that they wrote here. So we're going to use this clue to put this and replace it right over here. Okay, let me use a different color. So this B is going to replace by the 3L. You cannot solve an equation with one equation with 2 variables. So we need to get this thing replaced. So we're going to get L plus 3L. Okay, so this B is actually, so Brittany's actually the same as 3L. And now we have a nice simple equation that we're going to put together right there. That's 1L plus 3L is 4L. Divide both by 4. And we get 4. L equals 4. So what is this saying? Lauren will receive 4 songs. Brittany will receive 3 times as much. Okay, so remember, you're trying to equal 16, so this has to be 12. Okay, so this is the answer right there. Okay, so I want to do a few problems from the textbook that's in your homework. And I would like to do 17. So 3 times, we're going to translate this. 3 times, well, 3 times what? Here we have a quantity. Okay, and that quantity is the sum, which is plus a number and 7. So this is going to be 3 times the quantity n plus 7. Okay, so that's a little tricky. If you don't put the parentheses, it is incorrect. Okay, so be careful with that one. Number 27. A number increased by 6 equals 3 less than, remember that's reverse, so we got to write this first and then this second. So twice the number less than minus 3. Okay, so that one's a little tricky as well. A lot of stuff going on there. So again, a number increased by 6 is less than, it's minus. So twice the number, basically minus 3. Okay, you got to write this in reverse. Okay, I want to do some geometry questions. That's in your homework. And this is actually the ones we can actually draw some pictures. All right, and number 40 already has a picture. So let's take a look at number 39. So it says dimensions of a deck. Jin is building a rectangular deck, keyword, and wants the length to be 2 feet greater than the width. What will the dimensions be of the deck if the perimeter is 52? So another keyword there. So let's read it again. We know, first of all, it's rectangular. Okay, the deck is rectangular. And then he wants the length. So this is width over here. And this is length over here. He wants the length to be 2 feet greater than, that's a math word there, that's going to be plus, than the width. So whatever the width is, he wants this length to be, whatever the width is, plus 2. That's what 2 feet greater than the width means. Okay, so he's expressing the length in terms of the width, which is actually good. Now, the other word, perimeter, you should know that from geometry, perimeter is adding up all the sides. Okay, so we know this is also W, and this is also another L. Okay, so the definition of perimeter is adding up, is the total enclosure or adding up all the sides. So that's going to be L plus L because it's a rectangle and opposite sides are congruent. So basically the better formula is just 2L plus 2W. Okay, because we combine like terms right there. Now all we got to do is replace this formula with the things that we know. So what do we know? We know that the perimeter is 52 feet. So this P is a 52. And we also know that the L is a W plus 2. So this L now becomes W plus 2. And that's what we need because we need everything to be in one variable. So we have 2 W's, which is good. And now we're going to solve this thing. So we're going to distribute. And then we're going to combine like terms right there. And now we're going to isolate the variable. divide by 4 here. So this is going to be 12. Okay, W equals 12. What will the dimensions of the deck be? All right, so what are these dimensions now? So we can say, hey, I just found the width, and we're going to need to find the length as well. So the width is going to be 12 what? Well, we've been using feet the whole time, so this is 12 feet. And the length is going to be, remember that it's 2 feet greater than the width. So if the width is 10, then the length is 12. In this case, it's 12, so this has to be 2 greater than this will be 14. Okay. Now we can actually check this out to see if it works. So basically, but you don't have to check. So we can say, okay, if I insert my 2 answers, am I going to get 52? So 14 for the length, 12 for the width. So 28 plus 24. 20 plus 24 is 52. So yes. Okay, it does check out. Okay, so the last one we're going to do is number 40. Enclosing 2 pens. Chuck has 140 feet of fencing. Okay, so that's how much of fencing he has laying around, or he went and bought it, in which he wants to fence in 2 connecting adjacent square pens with fencing between the 2 pens. What will be the dimensions if the length of the entire enclosed region is to be twice the width? Okay, so first of all, we know the total, okay? The total fencing. That includes this middle part here. Okay? So this time we have a total fencing. And that total is going to be made up of, now we have a length, and we know there's another length there, so we got 2 L's. Okay? And then the width, we have a width here and a width here, but it's not going to be 2L because there's another width right there. So we got 3 W's. Okay, so 2L plus 3W. All right. Now, what's the other clue here? Right here, what will the measure? The length. Okay, so L is going to equal what? Twice the width. So twice the width. 2 times W. So all we're going to do is replace now the total and the L. So the total was 140. The L is 2W. Okay, and the other one stays the same. So now we have an equation we need to solve. That's 4W plus 3W, which is 7W. And then divide both sides. So we put those together. Divide by 7. And we get 20. Now, what will the dimensions be? So we need the width, we need the length, so the width, we just found it, 100 is 20 feet, and the length is twice as much, so that's 40. Okay, you say, wait a second, that doesn't equal 140. That's because, remember that our equation is right here. Okay, so basically, if we label this, this is 20, 20, 20. This is 40, this is 40. Okay, so 40 plus 40 is 80, plus another 60 is 140. Okay, so this checks out. Alright guys, so sorry for making a super long video, because it's two sections in one. So definitely make sure you have watched the entire thing and written down any notes that I've put down on the side for a video check. Alright, see you in the next video.